All right, cool. Hey everyone. So yeah, I'm Chip. Yeah, I've done a lot of random little things with Python, right? Python is really cool because you can kind of do all kinds of stuff. And what's fun about that is that you can stitch all these things together. So you've got LLMs, you've got robots, and you've got websites. You can mix it all together. It's a lot of fun. So what we're going to do today is we're going to use Python to do some art, some really basic art, but you're gonna see sort of kind of how it turns into something very complex, or you can make something very complex. So we're gonna sort of build some of the base, the bare bones stuff, and then you all will have enough to go back and build all kinds of cool things. So, how are we gonna do this thing? Hello. Hello. So how are we going to do this thing? There's a lot of ways, right? There's a lot of libraries out there. Python's just full of all these libraries that do all kinds of things, NumPy, whatever. There's in the case of image things, there's Cairo, and there's built-in XML libraries. We're not going to do that. We're going to take the easy route, and we're going to basically build some SVG files ourselves. I'm going to look at my README. Y'all can see the cheat sheet while we're doing it. Yeah. So we're basically going to take Python, build some functions to help us sort of build out SVG files, and you'll be surprised because you'll find that one, just kind of concatenating some strings and things like that is going to allow us to honestly get pretty far. And it won't be a perfect XML parser, but it's going to be a lot of fun, and you'll probably be able to build a lot of art that you want to build. So let's talk about SVG files. SVG is an image format, scalable vector graphics. It is a vector format for images. So like if you look at a PNG file, that's what's called a raster format. That means that it's a grid of pixels. And the good thing about that is that you know how big it is. The bad thing is that if you need it to be bigger, too bad. It's as big as you got it. So SVG is scalable vector graphics, and so an SVG file is going to be an XML file. It's going to be full of all of these instructions for how to draw some stuff. So this example you see here, for instance, that's an SVG file, and it's telling the renderer to draw a circle. And there's a couple of things worth pointing out in this SVG file. So again, I'm going to assume most people have probably seen XML type stuff. So kind of a brief overview. We've got these sort of tag here, this SVG tag, and there's these things called attributes. Like viewbox is an attribute, and this XML in S is also an attribute. And more, we got this sort of tag inside of it called a circle tag, and it's got some attributes of its own. So what do these attributes even mean? So we'll talk about this. Again, we're going to cover some of this sort of kind of boring stuff at first, but then we'll start building things, and it's going to be really fun. It's going to happen really fast. So let's first talk about a couple of these attributes and why we care about them. So this namespace, XML NS means an XML namespace, and so you're going to need that because that's going to tell your renderer, your browser, your image previewer thingy. It's going to tell. I'm going to stand near the mic and remember to stand near the mic. I probably got really quiet all of a sudden. It's going to, hey, come back here. That's me. My computer went to sleep. That's going to tell your browser renderer how to deal with all the SVG tags. What do they mean? What is an SVG tag? What does a circle tag mean? So, wait for it. We're talking about this view box as well. So I can see it, you can't. There we go. Okay, so this view box is these four numbers. What this view box means is that saying, in this case, there's four numbers. First, you see these first two is like an X and a Y thing. I'm gonna go over the little mouse a lot more often. And this is sort of defining a viewing rectangle of the file you're looking at. Again, we're kind of in the weeds, and I promise we're going to get to building some stuff. But what we're basically doing here is we're defining, start a rectangle, a viewing rectangle at 0, 0, and then make it 100 by 100 wide. So this is sort of our width and height, and this is our X and Y. And you can probably guess what these are doing. These are the center of the circle, and the center points of the circle, and how the big around, the radius of that circle, sorry, how big around. So, okay, so it's all that. Let's see what that file looks like really quick. Let's do some commands really quick. Great, and then let's open that file, and we're gonna just paste this in there. You can kind of see what we're working with here. That one. That's right, it's not gonna open because I have it ignored in Git. So, great, it's kind of highlighting Let's go to my browser. I have, oh no, is it gonna hide all my screens? Is it only showing, oh there it is. Oh, that's the old file, sorry. Okay, so there's a circle. So what do? We defined the view box and we defined a circle. We put it at 50-50 and gave it a radius of 50. So what that's gonna do is it's basically gonna fill this whole screen because it's a 100 by 100 viewing area. So how can we do this in Python? The short answer is, well, we could just write some code to print this to the screen and then put that in a file somewhere. Print and then redirect with your arrow, not a pipe, a redirect, right? So I always get this mixed up. So that's what we're going to do. So, but let's go ahead and what I want to do is let's start by doing this in kind of a generic way. So what I want to do is I want to build a function that can just kind of spit out these tags. A question? Oh, okay. So what I'm wanting to do is build some code to write these tags out. So here's what we're going to do. Here's what I want it to look like. So as you can see, that's the end. We did it. No, I'm kidding. So we're some things. We have these attributes, something like that. And so the way I might want to call this is something like. Great. So that's kind of, well, let's make a match at least. So that's kind of how I want to start by doing this. So we're going to write this tag function really quick, and we're going to do some really what I would say is sort of these kind of very idiomatic Python things. So it's going to be a lot of fun. So let's start by doing this thing, and I have a backup. If I mess it up, you'll get this. See me copy paste that right on in there. So. Oh yeah, okay, so we're going to talk about what this quargs thing is, and I'm sure this is a good Python quiz question. So let's start by, so we're going to start by sort of building out this SVG tag. It's going to have an open and closed tag like that. So let's start by, I'm going to use a few things, and I'll explain what we're doing in a second. Okay, so going through the process here, we're building out sort of what you see on line 4. So we've got the SVG in there. We need those attributes in there. And so the way we're going to do that is we're going to pass these keyword arguments, and that's what that KWR stands for. So what you're seeing here is we had to define parameters to this function, A and B. Those aren't defined there. So what happens is if you define this sort of quargs, the star quargs thing, what this allows you to do is pass any sort of generic keyword arguments and then get those as a dictionary in Python, a dict in Python. So what we're going to do is we're going to take that. So right now, with this call, quargs is going to kind of look like this. It's going to be a dictionary with those values in it. It's going to look something like that. And again, if you've been doing Python for a long time, this is maybe old hat. You've seen this a million times. It's always good to kind of go back over it because I always kind of get it confused. So what we're going to do is we're going to take those and we're going to loop over and we're going to make those the attributes you see inside that SVG tag. So what we're going to do that is we're going to say, I'll show you. Is it? Well, is it values or is it items? Does anyone remember? No. Items. Thank you all. Thank you all. It's items for the viewers at home. So what we're going to do is we're going to let's add a little space in here. You can see where this is. I think you all know where this is going, so that's great. Whoops, there's not the right word letters, is it? So we're going to go format string again. I'm going to say attribute name equals, and we're going to use single ticks, and yes, that can be a problem. And we add a little space in there. Cool. So lastly, we're going to add our closing tag, and we're going to, and then we'll talk about how we deal with some of the internal stuff. We'll get to that in a second. And there's your close. And this is not exactly what you see here, but we're going to get to that in a second. So, okay, great. So let's see what we got. what do I call this thing? Scratch dot. Oh, come on. Scratch.py. Oh, what did I do wrong? Because I'm trying to run Python code in there. That's what I'm trying to do. I've got my things all mixed up.
It's like, wow, you got some fancy shell stuff.
Yeah, buddy. I'm telling you. I am. But I really use Vim in my deepest heart of hearts. So that's why I'm like very clumsy right now. Like I'd rather do this in Vim. But so anyway, so we've got an SVG tag. It's got some attributes. It's kind of matching what we want. But let's go back and look at our reference really quick. We're going to handle one last little thing, and then it should start taking off. So we've got this internal circle thing, and so we needed a way. So in XML, HTML, all your whatever MLs, there's this kind of concept of you can have a tag and then tags inside of it. That's called children. And so what we need to do is handle how we're going to deal with children. And also there's another little aspect we need to handle here, which we kind of are already. If you notice this SVG tag, when it has these children inside of it, it has to have a separate closing tag. But if you look at the circle, that's called a self-closing tag, I believe. I think that's the word for that. And that means that there's not like a slash circle over here. It just kind of closes itself. That's a common thing. You'll see a lot in various SVG tags and stuff. And so we're going to handle that really quick. So the way we're going to do that is we're going to pass some children in here. Come on, you. Children is a list of stuff. So here's what we're going to do. So if you don't give me any children, again, we're going to make some assumptions here. This is not perfect. If you don't give me any children, what we're going to do is we're going to close the tag and return it. So if we don't have any children, let's do basically what we've been doing. Get out of here. Just like that. But if we have some children, we'll talk about what exactly children is, but we'll get to that in a second. What we're going to do is we're going to take all those children, concatenate all of those together, put those inside the tag, and then do a closing tag. And so that's going to look like this. So we're going to say output. First, we're going to, that very sign you see there is that one right there. And then what we're going to do is we're going to take all of our children. And again, children's going to be a list of strings. That's how we're able to do all of this. Then our closing tag. Okay. So again, if you give me any children, I'm going to add those in as underneath that tag, and then I'm going to close it. If you don't give me children, we're going to just close it. So let's see what that looks like real quick. Should work the same. Great. Let's add some children. Let's call it tag. Let's call it circle tag. And we'll add some attributes to that too, right? So cx equals, I don't know, let's do 50. Yeah, you're gonna see that we're gonna do a little different in a second. I'm deviating from my notes a little bit, so I gotta like recover that in a second. So now if we run that real quick, great. So you'll now see that our code did, for the most part, handle that. We got our attributes there, and we've got the self-closing tag for the circle, but SVG does have a closing tag like that. So
hey guys, do you feel it will be better if we turn it live?
Sure. Is the contrast?
Yeah.
Okay, pretty low. Okay, sure.
So from back here, it's
yeah, definitely great. I love it. Very good. Okay. So we did all this work to build XML tags, and it's like a lot of work. And again, there's tools in Python that can do this for you. But the nice thing about we're doing this is there's no imports. This is just a single Python file. I'm going to steal my implementation that I wrote here. This should be exactly. Ooh man, I'm getting a lot of input lag. That's not good. I can't even scroll. See that? Isn't that wonderful? You can see kind of where my version that I built as an example. Yeah, I can't even scroll. That's great. Doodaloo. Wait for it. Oh man, I can't even highlight, y'all.
Is it because just the HDMI?
I don't know. See, it lags. Look at that. I'm trying to highlight, and then we spin. Wait for it. Well, what we're going to do next, while that's deciding to highlight or not. So we're going to take that tag function we just built, and then we're going to build some functions to print specific tags that we want. And so one of those tags we might want is, well, an SVG tag. And again, what this is going to do is give us a function called SVG. And so if you've ever done like React, I know this is not the React.js meetup or anything like that, but if you've done React without the JSX stuff, right, it's like almost like you're calling these little functions and you're passing nested functions. We're kind of moving towards that. We're actually kind of building something similar to that, like non-JSX version of React. Let's see if we can print this. Get this to copy. Yay. Okay, good. So what we're going to do is we're going to build our little function here, and it's basically going to call tag, but it's going to build out SVG for us. Now, one thing we do is that we go ahead and we set a couple attributes that we know we need: XML, NS, and viewbox. Notice that I set the viewbox kind of differently than what we saw. So when I set viewbox to what I did, the reason I did that is because that's going to give us a rectangle that's 4 by 4 and centered at 0, 0. And that's going to make some of the math work out really pretty. It's going to just make some of the things work out really nicely as we build it. All right, so.
And what kind of units are used for the size of the viewbox? Or is it just like random?
It's just internal units to the SVG. So like, imagine if you had embedded an SVG file into an HTML page, like it's an image tag, you can set it to whatever size you want, and then SVG calculates positions of stuff based on the sizing you did. So putting something at 0, 0 within that viewbox will put it in the middle of that rectangle, whatever the shape and size of that rectangle is. Does that answer the question? Mm-hmm. Okay. So it's really about what you put it in, but this is sort of local to within the SVG. Okay. So and again, you can use whatever viewbox you want. You may need a bigger one for what your project is. So we've got that. Let's go ahead and build one for circles as well. Oh boy, inputs. Input delay. Is it? I think it might be the HDMI.
Yeah, that's bizarre.
I don't think I've ever used this with HDMI, so maybe it's just like a new problem. So let's do the same thing. Well, I already wrote it, so I'm just going to steal it. Ta-da! Okay. Notice something that what I am doing here. So let's paste that in. So, kind of what you expect. There's a CX and the CY and the R. Again, the center and the X value is the center of the circle, the Y value is the center of the circle, radius. And then we go ahead and do those keyword args again. And the reason we do that is because there are other attributes that you could provide to a circle. Maybe what color are you going to fill it in with, what color are you going to put on the outside, things like that. And it can get very complex very fast. And so we're just kind of leaving the door open there. Okay, great. So let's see if we can let's add a circle. Let's build an SVG file. Whenever you do a demo, something, right? Always something. So, okay, so let's do this thing. So output equals, let's do an SVG file. And one of the children, whoopsie, is going to be a circle. And then because we've now got a view box where we're centered at the origin. Let's do a circle with at the center of the file. And then we're going to look at this in the browser in a second, and we're going to give it a radius of, let's say 1, and then no keyword arguments. So let's just see what that looks like really quick on the terminal, and then we're going to put that into a file and look at it in the browser. Let's get rid of my hello world up there, huh? That's probably going to make some invalid. You're the man behind the curtain. Take a look at that again. Yeah, so great. So we got some SVG going. It's got our namespace, it's got our viewbox, and we've got a circle. Great. So let's put this. Let's dump this out to a file. Let's look at it in the browser. I'm just going to do that with the old redirect. And then if we refresh, great. So we have a circle in the middle of the browser. And if we do the old Spec element, you can see this is it's valid XML, and all we did was concatenate some strings together. That's all we did. I covered a lot of kind of random, kind of nitpicky stuff. Does this all make sense so far, everybody? Okay, cool.
Is it the browser that's doing the closing on the circle tag that way? Is that different from your output?
Yes,
Okay.
that's right. Yeah, so the browser, I guess, parsed the XML and then said, hey,
Choosing to
I'm going to turn it away from this. I don't want it to be a self-closing tag. I don't know why I did that, but that's what I did. Okay, so.
I have a question.
Sure.
How do you select the color?
Let's give it a shot. There is a attribute for that. It is called fill. Let's try that. There you go. And that's the nice thing about passing those quarks through, because we can just add our own fill to that. And again, you could even say, well, I want to have a red circle function that override, by default override all this stuff, right? And so you can see how the quark stuff and sort of the way functions kind of work in Python, you can kind of really build out some really cool building blocks. So not a ton of code, but we wrote like 25-ish lines of code of like code, like this is, does some stuff, whatever. This SVG is just kind of calling something else, right? So, well, I would scroll to the bottom when we may be switching to Vim, my friends. We might be.
Okay, while we're waiting, let me ask you again,
Sure.
you make that circle transparent?
Yes, good question. So the way you would do that. So you notice I said, Phil, I just gave it the word red. And for those of you, if you've ever done colors in the browser, there's lots of different ways of providing colors. There's a whole dictionaries list of words that are available colors in the browser. Things like red to cornflower blue and stuff like that, right? But then there's also things like these kind of function-looking things like RGBA, and so you can provide things with alpha. Is how you get that transparency. Is you would provide an alpha value. So there's lots of ways to do that. I don't remember does anyone know off the top of their head, is that RGBA, is that 0 to 1 or is it 0 to 255? I remember.
I think it's 0 to 255.
Let's try it. Okay. Let's try it. So let's do 255, 0, 0. And then we'll just,
0.5?
Sure. Let's give it a shot.
Pink.
Yeah, it should be. Hey, there you go. And so we're seeing the white come through. If we had more stuff, you could see the overlap and stuff like that. So that's how you would do that.
Okay.
And again, these are all, we've done all these functions to do all the string building. You could even build the functions to do this kind of stuff for you too, right? You can do the darkening, color darkening, color blending, stuff like that. Okay, so cool. So we can draw a circle. We've made our art. If you really got the artist mindset, that could be art. Right? Right? Okay, so all you have to do is just believe in yourself. That's art. Okay, so let's talk about how can we do more. So the place where Python is going to really, really beat you as an artist is that it can do a million circles, right? It could sort of spit out a bunch of circles and get the positions all randomized, all kinds of fun stuff like that. So we're going to build that. The first thing we're going to build, I don't know, for all of you Python folks, I don't know if y'all have had to build this. I've built this like a million times everywhere I go with this sort of F range type thing. Okay, I'll show you what I mean. It's like range, but it goes decimal steps because range doesn't support decimals, and I just always seem to need that. Someone have a question?
No.
Okay.
Is that standard library? Or is that a different package?
I'm about to write it.
Oh, okay.
And we're going to learn about generators in the process. There you go. So secretly teaching all this random stuff. Okay, so let's write this. We're gonna write another little helper function if the editor will behave. Wait for it. We might be going to terminal land.
Is it accepting like keyboard inputs?
I don't know. Sometimes it will just kind of not. So here we go. Sometimes I don't know if it's scroll or just keep. I don't know what it is. I'll keep an eye out for it. I'll see. I'll let you know. So let's do this f range thing. So what do I mean by f range? So so for those of you who may have seen this in Python, one thing that's kind of cool about Python is like the way for loops work, right? Is that you have to give it. If you've done a for loop, like in say in C or JavaScript or something like that, you know, it's kind of like a while loop, but kind of hidden from you in a way, but not really, right? Because you can write a for loop in those languages that won't terminate. You know, you mess up maybe the way you do your incrementing or something like that, right? It's a foot gun, right? There's a lot of ways we make mistakes. Python, however, has this concept of an iterable. For loops can just handle them, and then if the iterable terminates, the for loop will terminate, and that's really handy. So we're gonna go something like that before, like the old range function, if you've seen that. So quick primer on the range function is you can give it some starts and stops, and then a step. And what that's gonna do is that's gonna give you this thing, this in Python, it's actually called a range object in Python 3, but it's sort of this object that can kind of give you values as you ask for it. An iterable, it's like a generator type thing. It generates values for you. And it's going to give you, the way range is going to work is it's going to give you 1, and then next time you ask for a number, it's going to skip 4 and then give you the number after that, which will be 5, and then 9. And then once it gets past 10, it's going to stop and say, I'm done. Or I've gone over the range of stuff you've given me. This is really helpful. In our case, though, sometimes we need to go over decimal values. Range doesn't support that. I feel like I read this all the time. I don't know, maybe it's just me. But we're gonna write this really quick. So here's how we're gonna do it. And I'm not looking at my notes. And if you may already see the bug. I'm gonna introduce this fun old yield word. Great. Okay. That's it. Okay, so let's talk about this. So I kind of mentioned this idea of like having a number, and it gives you the number, and then it waits for you to ask for the next thing. And that's called a generator in Python, or an iterable. It's muddy, and I always get it mixed up. But
you're,
go ahead.
So so X, you're not you have X as an object A. So isn't that usually like a number?
Yeah, I mean, I could be strict.
Oh, you did that. Okay, I thought that was the bug you were talking about.
Oh yeah. Well.
Oh.
Yeah. So I mean, these are my intention is that these are all floating point numbers for certain.
Right, within the function.
Right. There is a bug here, and we can talk about that if we want. But so basically, what we're doing is this function, whenever it gets to that yield, and someone's asking for this iterable thing, they'll give you that whatever it's yielding out. It'll give you that, and then wait for you to ask for it again. And as you do that, it'll just keep yielding stuff to you, so giving stuff to you as long as you ask for it. And when it hits the end of that function, it says, I have nothing left to give you. And then if you were to for loop over this f range, it would give you all the numbers, and then hit at the end and stop. And so I'll show you what this looks like really quick. So what we're going to do is we're going to do for x in f range, we're going to go from 0 to 1, but we're going to go in steps of 0.2. I'll show you what values it's going to give you back. And let's see if we, and I'll show you what the bug is. Again, we're cutting a lot of corners. You'll see there's all these little bitty corners we're cutting. So let me show you what this f range does. Great. So again, so what we're doing is we're starting at 0 and stepping by 0.2, and we're going up until we get to 1. Notice that we don't get to 1. We don't give you 1. It's exclusive on the top part of that range. Where's the bug? What if I gave you, that? Is that right? I don't know. There's what's right behavior for some of that kind of stuff, right? So like, it only knows. It doesn't know how to handle going backwards and stuff like that. I think range, if you've used the range function, I think it can handle different directions. Our code is not smart enough to do that yet. We have to do a lot of stuff. I don't want to do that yet. So let's get back to art. Okay, so let's go back to our little SVG file. Let's kind of remember what we got here. Okay, great. So we're going to use this f range, but we're going to build a lot of circles. Here's how we're going to do it. Let me go steal the code because it's much easier that way.
So are you keeping it by providing the open range instead of closed range? So are you keeping the strict class, or do you need the right edge to be included?
You can do it either way. It may be helpful for some things that you're trying to build when you want the exclusivity, but sometimes you may want it to be inclusive. We can do it either way, and we can try it both ways and see. In our case, we're just making kind of cool pictures, and so you may be like, oh, you know, I do want to kind of get the end on there because it makes it easier for what I'm trying to draw or whatever, you know. So you could go either way with it. So here's what we're going to do. We build a bunch of circles, and we're going to build a lot of them. We're going to build 10 of them, if my math is right. Yeah, so we're going to loop from 0 to 1, and we're going to create a bunch of circles, kind of well, you'll see how it looks in a second. And yeah, let's give it a shot. Let's see what it does, and then we'll talk about it. It's probably the easiest thing to do. You know, I need to put circles in there. You can see that there. You can see that I was playing around with the fill blue because I had a feeling I was gonna remember to do that. So this music is very peaceful, by the way. I'm loving it. Okay, so I'm just trying to get to the console really quick. So down here at the bottom, is that? I just thought is that font small, y'all?
Yeah, it's not small, but so.
We, you know, the power of technology, man. We can just blow it up. Go away. All right, here we go. All right, it's kind of a mess, anyways. But you can see that we got a bunch of circles now. Let's see what this thing looks like really quick. Okay. Oh, there we go. Welcome back. Whoop, 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 whoop. Fingers go. Okay, good. So let's go look at this thing. Oh yeah, making some art now. Woo! Okay, so we got some dots. So what we did was we looped from 0 to 1, and we made a bunch of circles with just that T value from our loop. I don't know if the door's in the way.
Yeah.
I don't know if this is going to show up in the vid, but yeah, so we're just taking that T value that we got from our F range and just make that the X and Y values, and we just picked a really small radius. And so we can, you know, we can make the radius bigger, we can change how we use that T value, we can do all kinds of stuff now. So now that we have circles and this kind of looping over whatever, we could put a lot of circles on here. So we could even, let me show this code really quick so y'all can see what I meant. Yeah, so it's getting clipped because it won't scroll, but this is kind of enough to show you. So yeah, we're looping from 0 to 1 with a small step, and that's our value that we're getting from F range, and we're just making that the X and Y value, and that's the circles that we're putting on the SVG. Nothing too crazy.
Probably worth pointing out that in SVG, X and Y, they go that
Very good,
down
yeah.
and over.
All right, so, okay, I'm gonna do this for the vid because this is very helpful. So when you're in school, right, you're taught that like that's the way X goes and that's the way that Y goes. But one of the first things they teach you when you take computer graphics is that's not how it works for graphics. That's X and this is positive Y. So Y0 is there and Y, I don't know, like 100 or whatever is over here. So as you increase Y, you go this way. And if you're to OpenGL, right, Z is coming out into your face. That's what they do in OpenGL, if I recall. I think most of your graphics these days. And I think that's a left-handed coordinate. I forget, but if anyone's done 3D vector stuff, you're always going, you're like pondering your hand like this. Yeah, I've done my share. So, okay. And, you know, which way is the cross product? So, all right, so awesome. Thank you for that. That's very important. So the first circle in this list, the one with the the Y of 0, well, no input, no keyboard either. No keyboard either. So I think sometimes starts thinking about stuff, you know? And I just really messed up. Whoopsie doodle. Okay, so yeah, so the first thing in the list is this one. Because Y increases it, you're kind of scooting down. So yeah. My big head was probably blocking that for the people watching the vid at home. Sorry, folks. Okay, so let's keep on rolling here. So, oh man, there we go. Oh man, trying to scroll. Ooh.
It's like it's getting worse.
I think so.
Yeah, I wonder
Is there?
if you change your resolution or something.
I don't know what.
I don't know. That's kind of a long.
Or just unplug it and plug it back in.
Yeah. So you know the old,
That might work too.
the real thing we learned at Python Frederick tonight, right?
Actually, yeah.
Did you
so
try
after
turning it off and on
not
again?
plugged in, did it start failing after your computer fell asleep and came back?
I don't know. Well, let's plug back in. And then nope. And now it locks back up right in the second. And of course I lost all that code right there. Let's Control Z that real quick. First keystroke there.
Use your arrows?
Well, I don't even get keyboard input.
Even the keyboard.
The
input.
keyboard freezes up on me too. You know, that's my very thought too. Oh, okay. So,
Okay.
We have the room till 9:30, so you got it.
Yeah, so we can ponder the mysteries of the universe as we wait to scroll.
We can wait for it to catch up.
All right, so we did this one. Let's take out. Let's do. Oh, okay.
Here we go.
Now, okay, we are going to do one import. We are going to do a single import. It's built in though, and I think it's not too offensive. We're going to import math. Okay. No, not math. And we got cosines and sines. We're gonna. Let's give it a shot. Oh man, we got some list comprehensions in here. I'm like secretly teaching all these kind of cool Python stuff in there. That was not the intention. I just like random things kind of came to mind. And
It has tau? That's awesome.
ooh, who knows what tau is? What's tau? Anybody know?
Torque.
What GK? Yeah, could be. Yeah.
Some sort of measurement or something?
Anybody? Okay. So pi, we all know like pi. If you do 2 times pi, sometimes people write that as tau, and apparently that's built in to that. So that's actually 2 pi. That's just 2 times pi. It's built in.
It makes the math easier.
Yeah.
Not have to do the
We have to write the 2 all the time. So either way, all right. Let's take a look at this bad boy here. Oh, come on, computer. I believe in you. Okay. So let's go take a look. Oh my goodness, this input delay is really cramping my style.
You've got your code on the right side. Maybe if you just go over there and click on the line you're looking for.
No, I'm not getting any.
No reactivity.
I wonder if it's
Do you wanna-
Visual Studio Code.
Do you want
It
to?
seems like it might be. Because your cursor's fine, right? Like,
Yeah. Okay. All right, y'all. Let's get real. Let's go.
You should have
Let's go. Let's go. All right, let's pull this up. This is gonna be really big. So it says skit, art, Python, Frederick talk. All right, let's go. Let's go. I don't have any. Let's go. All right. Ooh, I do have. Okay, much faster. Great. Okay, and then be gone. Okay, so great. So let's do readme. Oh yeah, like I'm like way more productive. Whoa, the productivity just through the roof. Okay, so let's do this old circular circles here. The old Y command, my favorite. Okay, so great. So what do people think this does?
Draws larger circles?
Yeah, so we're drawing circles in a circle. You did the circle hand, calling it you. So we're gonna go in a circle and put some circles. And if you notice, the radius is going to get bigger as we go. So we're going to start small and get bigger and bigger. It's going to look kind of cool. So let's try this thing out. And of course, now that we have the productivity of Vim, we can do anything. So there we go. Oh no!
Invalid syntax.
Oh no! What did I do wrong?
Maybe a spacing or something.
I forgot a comma. I forgot commas. Oh no! Because I think my
Oh yeah, CX, CY.
yeah, I named them different. Yeah, that's right. Whoopsie doodle. Anyways, ho! Now we get some art. Okay.
Took a little movie spinner.
Nice. Okay, so you can see how it's
Wait, so did you
beginning.
make the step 0.01?
Say that part again.
Did you make the step 0.01?
Let's see. I forget.
Because I missed that.
Yeah, let's take a look.
Yeah, it's small.
Yeah.
Yeah, smaller step. We can play with that step as well. So let's try even smaller step and see what kind of. Yeah, so it begins to smooth out really well. And again, doing this by hand would just like not be possible. I know it would be very tedious, especially when you see how many circles there are. Okay, so yeah, so we started. We're basically putting circles on a circle as we go. You're good, you're good. And we're increasing the radius as we go around. So you can kind of see, I might do that. You can also do any path, right? And make, do anything you want now. So, okay, so let's go. So that's.
Can I jump ahead like 15 steps? Can SVG be animated?
You know, that's the idea for my second Python art talk. So that was actually my second follow-up talk. You're the second person who does this. Yeah, so there is built-in. Yeah, there's animation built into SVG. There's an old way, SNIL, and then there's a new way that I haven't actually went back and learned. So I would happily go learn that. And we can just animate it stuff in a follow-up if y'all like this. So cool. So that's that. Let's do some color. Okay, now it's about to get. Now it's about to get real, and Franco, this is for you, my friend, because this has exactly what you were asking about.
Okay.
So, all right, let's talk about that. Actually, this is syntax highlights, so let's do this one on that side. Okay, so same old. We are looping. I forget why I picked the numbers I did, because I wrote this like a couple months ago, but
From 0 to 5 incremented by 0.01.
Yeah, so we're gonna go a lot of t values here. Again, this is just an angle, theta, and it's from up to 10 pi. Again, we're setting the radius of our. We're basically building a spiral here. Again, more circle stuff, but this is your hint that we're making a circle. But something interesting though is that the radius that we're kind of using for the circle, this part, is actually increasing with t, right? So you're going to start seeing this kind of go out like that. Mm-hmm. And then we're going back to what you were talking about. We can use this RGB function to kind of come up with colors, and apparently it is 255, isn't it? So yeah, so we're going to use the circle's position to try to kind of figure out the color. And I think there's probably some math problems here with some negatives, but you won't worry about it too much. We'll just see what it does. Whoops, if I can save. All right, let's see what happens. Okay, there we go.
Nice.
You're all getting very sleepy. It's all my ruse. You hypnotize every one of you in this room.
Right, so listen, you can send it to print right now and put it here.
Yeah. Okay, so the fun thing, so I'll so let's stop here for a second, because I want to give a little background, because I had some ideas for building some art like this, and I was like, I want to do this in Python, and this is kind of how it went about. I was like, oh man, I could just like write SVG like really easily with Python, just build some strings and stuff. And again, all this is on GitHub. I'll make sure I share it with everyone so you can steal the little snippets and build whatever kind of cool stuff you can think of. But I was like, this is a lot of fun. I'm just gonna do all kinds of stuff. I was doing fractals and stuff. It was like super fun. But eventually, you put too many things on there, your SVG renderer can't handle it. And so this is where you might want to switch to raster, right? When you have a fixed number of stuff. This is where the trade-off between raster and vector can really become apparent. And again, we're like, I don't know, a couple hundred circles or something like that. There's quite a few up in this area, I think. But okay, so you can see how we.
So which part of the code contributes to circles not overlapping? So the radius increases, but also the spacing between them increases too.
Yeah, can you jump into the code?
Oh yeah, let's take a look. And honestly,
because you use the radius as a part of X and Y.
Mm-hmm.
So they are spaced more further apart.
Yeah, and I didn't do any algebra to figure that number out. It's all kind of empirical, right? I just kind of arbitrarily kind of played around with it until it looked quite a lot.
What does theta mean? I totally forget. So like I don't know. Why are we using theta rather than just like t?
honestly, it's just math brain, because a lot of times in math world, you'll see people write angles as theta. Like that's the variable they use for angles. And I just sort of, to tell myself in my brain that, hey, this is an angle, that's why I call it theta.
It's like
In
thinking in radians, basically.
Yeah, kind of, sort of, right. It was almost like a marker for me to tell me, hey, this is an angle.
Okay, radians, duh, like 2 pi.
Exactly, you're in radians, yeah.
Okay.
Yeah, exactly, which is, yeah, so you can think, again, this is an angle, so as I put this into math, the cosine and sine and stuff, I'm like, oh, because it's an angle, of course I would put theta in there, but that's
So
just, that's,
chunking through this step through the circle at little small increments.
yeah, you're incrementing the angle essentially by, you know, portions of 2 pi, basically, so.
Got it.
So you can consider like t to be a representation of angle in degrees. I mean, if you convert it
Kind of, sort of, yeah, for sure,
to
for sure.
90, and then
Yeah.
theta is degrees converted to radians.
Yeah, and really, like, for me, in the math sense, I always think of t as just like a parameter, right? A parameterized function or whatever, right? And so you can do whatever you want with t, and generally t actually is 0 to 1, right? If you look at, like, you know, you get into like calc 3 and stuff, it's always 0 to 1 for some reason for t. But you take that and you map that into an angle or something via the mechanics of some math stuff and some calculus things.
I
But
think because of your step two, it's like literally 1% of the circle for each time of the loop. Because it's at a 0.01 times
Could
2
you
pi.
just
Yeah,
like,
true.
for my...
oh no.
Oh no.
Oh no!
I think with the power of them, we're safe.
Yeah, if you change the 5 to like 3.60 to like sort of be like represent a circle,
Oh, sure.
is my brain right in thinking that if we're going in that, we make like, well, no, that does not seem like...
Well, here it
So-
won't work because you increase the angle which with every step.
Oh, also,
you will not get the 360.
I bet you if you made it 1.
yes, it's
One-
gotta be
one is a
one,
loop.
because
Yeah, you
that's a
free
full
those
circle.
numbers.
Tau is a full time around the circle, so really you just need an integer here, and that'll give you an integer number of times around the circle. So let's try 1 really quick, and you can see what I'm
5 loops. The 0 to 5 is 5 loops for the
Oh,
5 loops
okay.
around the circle.
5 times around the circle, right. Now again, this is,
Yeah, you
Oops.
will get more than one.
yeah. 1 time around the circle.
Well,
You
no,
should.
that is one time around the
Yeah,
Yeah,
it just
it
expands, it's hard to tell.
Yeah,
So-
got it.
Instead of saying around the circle, around the, around the bend, right, because that,
Yeah,
because
around...
there's the 0 mark,
Around
and
the
as you
compass.
swing around, yeah.
And I'm like, sorry if everybody else thinks this is dumb,
No, it's
but
okay,
I
it's great.
totally forget what cosine and sine and all that stuff. Like, I've not heard those words since.
Whiteboard time. We can do whiteboard if you want, but
Get us intrigued.
I'm happy to. Let's kind of keep plowing through some
Okay,
of these cool
yeah,
examples,
let's
and we can talk about math because I'm happy to like, talk about
let's
math.
not
because
go too deep into that stuff. I wasn't sure if
There's
this
one
was like
thing about it, like the x and y on the unit circle a little bit.
Yeah.
okay.
Without getting too much.
Yeah, well, yeah. We can
Show us a triangle.
draw the triangle, and then
Sorry. I'm just like, man, I have not thought about sine and cosine in so long. I don't remember what they mean.
who you know, a lot of people, you know, there's very specific places where people use that a lot, but then outside of that, you know, I mean, and of course, sometimes it shows up in places where you didn't expect it, right? I was in so again, a little bit of my background, my graduate work was in applied math, which is why I wrote math and cosine, because I did a lot of it. And it was the same thing for those of you who have ever done, especially stuff, people in data science. Linear algebra just kind of is everywhere. It's
Yeah.
everywhere. And if it isn't, you rearrange the problem so you can make it linear algebra because you have all these great tools out there for handling linear algebra problems, you know, least squares regression and solving systems of equations, QR factors, all that kind of stuff, right? So a lot of this is kind of a similar thing, right? Where sometimes they're out there and you kind of are able to kind of ignore them because they're sort of kind of hidden away by a library or something like that. So anyways, I've been doing a lot of geospatial work lately, and so this kind of stuff pops up a lot. So cool problems out there.
Brought that up because I was just thinking, at the beginning you mentioned there's no imports or anything, and what it occurred to me is that if you are in a GeoEnt environment and you need to make a quick demo because your client needs to see an area of interest, I see how you're building a circle do I, instead of bringing a white canvas to draw a black circle, I just bring a map. And then, is this is how you like the circle to render? You want it to be thinner, you want it to be wider, I mean, wider. So-
And it's getting the geospatial stuff like KML, which is like a format used in that. It's like, okay, yeah, we got the geo folks around here. What's up? Okay, so it's XML, right? So a lot of these things we're doing here, we kind of applied to KML. Again, there's way better KML builders out there for Python, but you can see how you could, again, throw together a little demo. You can put some circles on a map somewhere, and then something to take to a demo and say, what do you think? Is this, so you're not spending a lot of time doing the not important stuff, and you're doing the important stuff, right? So there's certainly a great lesson there. Okay, so we did a lot of circle stuff, but there's a whole bunch of other SVG tags out there, and we're not even going to get close to covering all of it. I'm probably going to hit the turbo button for all this because I know that I want to be mindful of everyone's time. So let's talk about other tags here. So another one is called the polyline. And what a polyline is you give it a list of points and it just connects them with a line. That's about it. So let us try this thing out, and you can kind of see what it does. Again, we're taking the same approach we did. Well, let me get over here so it's nice and syntax highlighty. Okay, great. So again, we're getting a lot of wrapping. There we go. Okay, so how to talk about this? Great. So we're taking a similar approach like we did with circle, right? Where we sort of there's a polyline tag out there in SVG land, and there's an attribute called points that you must provide, and you give it a comma. You give it pairs of points, pairs of x, y coordinates. The x and the y have a little comma, and you put a space to separate coordinates. So I'll give you an example of what that might look like.
Wait, did you just autocomplete the word polyline?
I did. It was Control N. I used the very basic.
How did it know?
How did it know? The computer always knows. No. So quick Vim aside. So what I did was Control N, and it basically looks at all of the words that it sees in the file, or in all the open buffers, I think, to be precise. And it just basically completes. So if I type LI, it's going to give me all the LIs that it sees in all open buffers. And this is just built into Vim. This is not fancy pants cool stuff, which there's way better stuff out there for that. I've actually always liked the low-tech version, and that's always worked really good for me. I have a really heavy JavaScript background, which has a really kind of meager, kind of standard library, if you will, right? So like, you just kind of memorize most of the things you need.
I'm in the cave.
Yeah. So, okay, so points would look like this, right? And so that would be like, that's kind of what a polyline would look like. And so we're building that here on line 41. Again, some clever, some list comprehension stuff going on. The way I'm thinking of it is points is a list of tuples of numbers. And so that's how we're doing this, like kind of, we could even do some tuple unpacking there if you're clever. I should have done that. That would have been cleaner. But yeah, so that's what that does. So let's give that a shot. Let's see what that looks like. Oh, I already have it. Cool. Oh, and also, we set the color here. We're doing some color stuff here. We'll talk about that in a second. You can see some hacks going on here. And again, there's better ways to do this. Just take the time to do it. Great. We have a line. It goes from 0, 0 to 1, 1. It's so exciting. But we added some attributes. We added a stroke attribute which says what color to make the line. And then the stroke width. That's how thick the line is. And notice, this is something that always bites me in SVG, is this is in units of your view space. So like 1 is very big. Like 1 is like this big here, right? Because this is our view box, right? So it's a very big space. So stroke width is pretty small in this case. You know, if you had a much bigger view box, you could maybe get away with a larger number. But again, something to play around with. So let's talk about how I did it, how we built this little example. It's not very clean. We're doing some fancy stuff here. So stroke, you know, we probably could have gotten away with like, mind you, Well, spaces. I'll try. I don't have them configured really well on this laptop yet, so I can get away with that. But there's this stroke width, and I'm doing some kind of gnarly looking thing here, and I want to talk about that. So, stroke. This will probably still work. Let's see. Let's find out. Great, still works. Good. Okay, but I did this kind of gnarly thing on line 51, and the reason is that in Python, right, you can't have a variable with a dash in it. But some attributes in SVG want a dash in it. That one, for example. And so the way I've actually handled this in more like robust code that I've done for this is I've actually made this an underscore and then converted underscores to dashes in that sort of that tag function you wrote really early back. That's how I did that in the past. You could totally do that with your code. I recommend it, but I just sort of kind of faked it here and unpacked the dictionary and kind of did some like a one-liner.
That was a cool little hack. I like
Clever.
that.
It's clever, but it just
Clever maybe in a bad way, but
it feels
cool way to
icky,
do it.
right? Yeah, you know, it feels very icky to me. But so again, we're just setting stroke and stroke width there. Those attributes can get a little messy. Let's go back to README. Let's see. Whoops, lowercase e. What do we? Whoa. Oh no! I skipped to the end, and now you see the final boss. I don't want you to see the final boss yet.
Did it freeze again?
Yeah, it did.
Oh no.
Not that, anything but that. Oh man, perturbing points. Oh my goodness, we're getting to fractals, y'all. Wait for it. Okay, cool. So yeah, so we we can talk about fractals now. Now we're starting to really get into the needy stuff. So I'm gonna paste all this stuff here, and we're gonna talk about each one of these little parts. We're lerping, not LARPing. Something different. Subdivide. Oh my goodness. We're really getting into some gnarly things. But I promise it'll all make sense mostly. Oh yeah. Subdivide all. Okay, so we're going to work on building a Coke snowflake. I think that's how you say that. K-O-C-H. I think it's actually pronounced Coke, I believe. Okay, so what we're doing, we're gonna, and there's your good old range. Okay, so let's talk about the Coke. Oh, come on, you. There we go. Okay, let's talk about this snowflake thing. I'm going Coke snowflake. So, thank you, DuckDuckGo, for helping. Okay, so we're not going to build some fractals. So again, what's really nice about code is it can do the same thing over and over again, and you don't have to, right? That's the whole reason I started doing this whole programming thing, so I didn't have to do it. So a lot of cool shapes out there are based on this idea of taking a shape like that, like that's the equilateral triangle, very powerful, exciting equilateral triangle, and then we can perform this sort of transformation on it, where we maybe cut out a segment and replace it with new segments. And we keep doing that. If we keep doing that over and over again, we get this kind of funky shape. You can kind of see how that's happening there. You get this sort of, what's a fractal? And I think the length of that border gets longer and longer as it gets, I don't know if it's infinite or not, I forget. But there's rules for doing that, for how you build that shape. So I'm going to build that shape really quick. Let's talk about all these little parts here. So basically, we start with the points of an equilateral triangle, and we're going to perform that subdivision over and over again. We're going to do it 3 times. We can change how many times we do it in a second. And then we're going to print out. So let's just print this out really quick. Let's make sure that example works, and then we'll talk about what it does. Oh no!
You're missing something from your paste.
Oh no! Did I do something wrong?
Yeah.
What did I forget? None type is not iterable. Oh no!
Go back.
Oh. What did I miss? Non-type
So
is.
there's like a return there, and then right above there's another return. But 563, and I just look good.
Oh
Yeah, that
no!
looks
What have I
a little
done?
funky if we're paired programming.
This is really good. Let's see if this works. Oh no! Subdivide all isn't returning something. Well, that's okay. If we don't get to this example all the way, that's okay. Well, if anything, I can try to debug this and show you all what this looks like in a second. But you can kind of see it right there. So, I can honestly, I'm actually kind of at a good stopping point, anyways. I think that was actually all the examples I have. I mean, I can certainly debug this and can show you all this a little bit later. Always post it in Discord, of course. But yeah, so. Thesis of this whole rambling thing that we just did was that we started with nothing. We started with an empty file. We added a couple little functions here and there that sort of built SVG from scratch. And then once you kind of started that snowball going, you can really take Python and not maybe not the craziest Python in the world either. I mean, we sort of did a for loop and built the spiral thing. That was a couple lines of code, and there's some math in there, you might have to brush up on your math a little bit, but there's a lot of cool opportunities here, lots of really fun stuff. This is all on GitHub as well, so I can certainly share this with everyone in Discord as well so that you can get a hold of it and kind of play around with it, build your own stuff. There's certainly places for improvement. I've done some cool projects with it, with this very little chunk of code, all kinds of stuff that breaks the browser, all kinds of fun stuff like that. But that's mostly all I had. I just wanted to kind of give you guys some cool tool blocks, some Lego pieces, and let you kind of build some cool art stuff and, go forth and have some fun. Thanks for coming to my TED Talk. And I should be looking at this thing. Okay, so questions. Anyone have any questions? Any comments? Tomatoes?
What do you feel the number of points or circles that get drawn before the browser crashes?
Sure. So the fractal that I did that for certain was crashing, in my case it was preview on the Mac, on this very computer, it was like 15,000.
Okay.
And honestly, what I honestly think part of it was, let's see here. Let's go back and let's do that circle example. Well, I don't know if you remember, when we print out the circles, right, there was a lot of floating point just like garbage, when it did that floating point math. And so each one of those attributes was like many decimals of precision. You probably don't need that many. You could probably truncate, make the file a little bit easier to parse, a little bit smaller, things like that. There's maybe some tricks like that. Again, so now you're getting into like some implementation details about how the browser does the parsing, which is kind of cool. But 15,000 was the magic number in my recollection. What you got?
Yeah, it was just making me think, like, I know that, like, for the kind of work that I do, like anytime you're using money, you like never use floating points. You use like the built-in decimal library. So I feel like maybe that would be an answer to fixing that problem. Yeah. What about the SVG window being huge and using
Right,
ants?
and working only in ints, right. Yeah, that could certainly do it. Again, you're still going to probably have to, like for doing circles and stuff, you're going to do sines and cosines, right? So you're still going to have to do some back conversion there. I'm sure there's probably some cool
The
energy
browser
only.
doesn't have decimal, so you'd have to deal with floating point.
Yeah.
No matter precision loss, no matter what.
Right, and again, SVG standard, like there's a whole bunch of other kinds of tags out there, so there's maybe other ways to work around those limitations using other tags, right? You could build a circle with a polyline, for example, and that may be easier for the browser or for a specific browser, right? There's all kinds of stuff like that. A lot of times people do image optimization for different sizes and network, but maybe there's actually specific, like for instance, when I was doing game development, we were using, audio in the browser. Some browsers support some subset of audio formats and some support others, and so you would have to ship both audio files. And then sometimes different bit rates would work better in different browsers because of the way the decoders work inside of Chrome internals and stuff like that. So in a way, you're kind of starting to kind of poke into the internals, like, why is it doing this? Why is it mad about this attribute being the way it is? Sometimes you'll actually find browser bugs this way. This is the kind of stuff where browser bugs like to pop up, right? Or you find actual bugs and stuff.
Not to mention that every browser will have its own quirks.
Right. Yeah. Because all of these are, nowadays there's a lot more overlap in the implementations, but especially historically, right? All these browsers have their own implementations of every one of these things, right? So the way that circle is written, the way that's implemented could be different. Circles may be simple, but like other stuff for certain. What's up?
Yeah, so do you know if we can draw a spline with the color gradually changing from between like point A, color A and color B?
I'm pretty sure. I have to look in exact how you do it. It's been a while, but I think you can.
Well, not necessarily a spline. I mean, any sort of.
I got a curve, and I would say it's red over here, and it's blue over there. I need to fade in between red and blue. I think there's a way to do color stops and stuff like that.
Yeah.
Iterate through the RGB numbers.
Yeah, so what you could do, and I think that's what you're getting at, you could do multiple little line segments and do each a different color and just have a bunch of lines and do the gradient yourself. That's messy. And then you gotta have some of the kind of the nice color utilities that we kind of talked about. But again, that's a workaround. There's probably ways natively in SVG to do all that, but I don't know if
I'm guessing it would not blend well if you tried to, I mean, you'd have to make them super small.
Yeah, again, but F-range to the rescue, right? See, I told you F-range is always safe the day, right?
This was good.
Can you show us what cosine looks like on a triangle?
Oh man, I sure hope so. I sure hope so. Wouldn't Yeah, we can do a quick cosine.
Trig 101 back
Trig 101. And it's going to be tricky because X and Y in math land and on computers it's opposite. It's the Y is flipped. So we'll just we can do we can do that quickly.
Why don't you put a negative and go?
I wonder if I can. I could do it with Grapher, but I don't. My Grapher skills are not very good. How do we raise?
There's a little remote. There's a remote back here.
I'll draw this a little window. I knew I was going to do some whiteboard math, right?
Turn the lights up. Yes, that's right.
Oh yeah.
Are you all done with the projector?
Yeah, I'm done. So give me some X, Y for it. You draw. Okay, you draw. Okay, good. So I got the X coordinate, the Y coordinate, and Y axis. Sorry.
Test on those.
Yeah.
Okay, so I'm going to draw a circle here. I'm going to give it a radius of 1. So this whole thing is radius 1. If you give me an angle, I'm going to use the magic angle theta, of course. What cosine and sine is going to tell you, this x distance, that's cosine of theta. That's what cosine of theta is giving you. And this y distance, oops, it's not cosine, just kidding, it's sine of theta. And what's interesting about this is that I drew it sort of only working this sort of kind of wedge here, but theta, as it goes around, so it starts at 0, goes to 90 degrees, goes to 180, goes to 270, and back to 360. The signs of the x and y's will flip, right? Because as you go around, whether the x, once you get kind of over here, x goes negative, and then the y goes negative, then x goes positive again, while y is still negative. And so sine and cosine handle all that. And so what's nice about that is they give you sort of a free way to kind of deal with circles and if I've got an angle, I can get the x and y coordinates of a circle from those two functions. That's like where it's useful for what we were doing. And there's all kinds of other things that sine and cosine are very interesting and cool at, but I'm sure you can do complex numbers and do fun stuff like that.
And what's the third one? Isn't there like
Tangent?
Tangent, yes.
Tangent.
Much more.
I'm so
There's
proud that I have to do this. You ready?
There's like 7
Who
more.
remembers this?
SOHCAHTOA.
SOHCAHTOA, baby. Woo!
That's
Okay,
it,
so SOHCAHTOA. So what the sign of an angle gives you is it gives you the opposite side. So for here, the opposite side of this triangle divided by the hypotenuse, which is 1 in this case. So the hypotenuse kind of cancels in our particular case. Cosine gives you the adjacent over the hypotenuse, which is 1 in this case, so the hypotenuse kind of cancels. Tangent, however, you can kind of write it like this. Another way of thinking about it is, is it?
Sine and cosine.
Yeah, sine over cosine, thank you. I was like, oh, crud, I can't remember. So we can do it that way. And for the art stuff, I haven't used tangent very much, but tangent looks cool. So if you were to plot tangent of theta, it kind of looks like this. It kind of looks kind of like that. Oh wait, no, I'm sorry, that's arctangent. Whoops,
Yes.
arctangent. Arctangent's very helpful. That's the one I was actually referring to. But tangent's kind of interesting. Let's look at that really quick.
That's the asymptote one, right?
Yeah, it looks like this, right? It's kind of got these squiggles that just kind of go on forever, and it's symmetric, but I can't draw very well, so it doesn't look symmetric when I draw it. And again, the reason it's got those asymptotes is because sometimes cosine of theta becomes 0. And so you're dividing by 0, it goes zoom and zooms off once you get close to 0 for cosine. Now, tangent in our case is pretty boring, but what arctangent is really cool. So if I look at the inverse tangent, if I look at tan of negative, arctangent or inverse tangent. Hey, Elvis.
Sorry.
Heck yeah, for Elvis, yeah. All right, so arctangent is kind of cool because it gives you the smoothing thing. So what it does is it takes, it's not an angle. What am I doing? It's put up a value in there. So if I give any sort of y value or something in there, or x, I'm writing this x. What am I doing? Okay, so if we have this, value, it kind of smooths that value out. And for those of you who have done machine learning, right, you start looking at like the neural network kind of logistic type responses and stuff. You start kind of sigmoid stuff, right? So it kind of gives you a way to smooth out some responses from an input that might be on or off, right? So that's where it's helpful there. But like for our cases, sine and cosine is enough. There's other cool functions out there that you could explore. They can give you all kinds of cool math ideas, and circles are just fun and easy. So, all right.
So what other kind of fractals you try to? What kind of fractals can you build with vector? Because I mean, like Mandelbrot, I think it's purely.
Pretty intensive, right?
Yeah.
Because you have to look at the entire complex plane and you do multiple iterations. Let me find the page while I'm at it, and then I'll show you one of the ones. There's some cool iterated function systems. Those are really fun and easy to do. I'll show you. Let's see.
Who knew we'd get a bonus math lesson with that presentation?
See if I can find it. There's a really cool example. Is this code? I think. I'll show you. Let's see if I can. Let me go dig through. Let's see what other builds I have here of some of my other projects. And you can see how I did some of these other things. I have to find it first. Sorry. It's a tractor. That's what it is. It's a stranger tractor is what it's called.
I think you might need to unplug and plug back in.
He's not checked.
I'm not in there. I'm trying to find it first. Boom. Okay. It's cool. So what's really fun is that there's all kinds of weird and cool math out there. Some of it's surprisingly pretty simple. With a computer, it makes it really easy to do it. So this is a cool example. I actually built a couple of these. This one especially I think is really cool. That one too. Okay, so this is weird stuff. So what's going on here is that there's this concept of an iterated function system. So you got a pair of xy coordinates. You put them into a function and they spit out some new xy coordinates. And you do that. You keep doing that over and over and over again. And what's interesting is if you take the entire plane and you run all those points through that iterated function system, they'll converge onto a shape. Sometimes it's a pretty boring shape, but sometimes you get this kind of stuff, right? With this GXQ guy. And what happened is they took all these points, ran it through an algorithm. Again, an algorithm, some code's going to be able to do this. It's just going to be hard to do this, and it's going to converge in this way. And there's many out here that just looks kind of cool. But you can see that it is indeed math, and it is indeed math. And so again, some hints that is iterated function system. So if you give me some x and a y, my first x and y, so those would be x0, y0 maybe. I spin them into this function, and I get some new xy's out. That's what the n plus 1 is telling us. There's some new xy values. And there's these coefficients, there's a's and b's and things like that. Well, in our case, it's just a's. But those different a values give different sort of pictures. And what's interesting is that we don't really have an intuition about why some of these look like they do and some of them don't. You know, we don't know. We have some ideas, some reasons why. There's all kinds of cool stuff like this out there where your SVG function and a little bit of Python can draw all this stuff. I actually have the code have some code that parse all this stuff. We can try to run it. Yeah, see, I even have like the little thing that decodes that coefficient thing we saw. Yeah, so you can see this is some of my tooling for doing some of this in a more like robust way. Let's see. Oh man, y'all haven't looked at this in a while. Let's see what's inside here. Who knows if there's any good in here. What's this one? That's the SVG. Let's do the PDF. It'll look better. So that's one that I was kind of playing with. It looks better on my screen. The colors are just you know, playing around with that. I did kind of I was kind of playing with like a mesh and kind of deforming it and trying to see what that looks like. Here's some circles. Yeah, so there's those same circles but they're only stroked. And again, it's kind of cool, you know, but that's all randomized, right? So once you start throwing in randomness in there, you can do all kinds of fun stuff. I don't know if...
It's interesting that your SVGs are bigger than your PDFs.
Exactly. This goes back to the decimal. I'm not truncating decimals. Okay, so I have a job for Sierpinski. Let me see what that one was called. Jobs, I think it is. Oh boy. No, it's in Bakes. I gotta remember how to do it. I haven't looked at this in a while. It's attractor is what it's called. Bake all attractors. Yeah. Boring circle. I like the name. I named that Bean, Warble, Bag. These names. I don't know what attractor. Is that it? Let me try that. See if it breaks. You know what the heck. Oh boy. There you go. There we go. See what I bake all. Come on, baby. There you go. There you go. That's a good error, right? I don't know what that means. Look at that. Clay with a K with a class with a K. Yeah, there you go. Maybe it's. Oh boy, I'm typing all kinds of stuff here. My Vimfu is not strong. Let's see which one is in here. Trifoil. See, I don't know. Remember how this works, but yeah. So I have I can parse these little codes and then do it. I forget how you do it though. Did I name these? I wonder if I can.
What inspired you to do this stuff? Just for fun, or
where did this come from? I don't remember because I have a whole bunch of these that I've built, and we can look at that how I do the SVG type parsing in a second. But how did I come about this? I think I saw some art somewhere. I was like, man, I bet I could make that with code. And the rabbit hole began. And we've now got, a job manager. We've got linting and testing, right? So what's up?
You know about GLSL, right?
Yes.
Shader language?
Yes.
I always think that's a really great kind of language for making really interesting
yes.
structures and art.
And it is, so for those of you who all has heard of GLSL? Okay, so would you like to, you brought it up, you're totally welcome to introduce it.
Oh, it's generally what defines shaders on your computer. The shaders are used in games, but they're kind of, the ones that usually run are called fragment shaders. They're looped over every single pixel on your screen, and depending on whatever kind of rule you program for the shader, it will color the specific pixel on your screen whatever color you plan it to. By using enough math and kind of a lot of computation, you can kind of make really interesting kind of figures, like things like fractals. Yeah, he's pulled up shader toy. This is basically what you can do with them.
Yes.
It's per pixel.
We can do that. We can talk about that too. I can do a talk on that.
Lots of fun.
Okay, so yeah, back in the old days of the late 90s, I think it was, graphics cards changed for the better, and they became a programmable pipeline where you could give it geometry and then give it individual pieces of code to sort of transform how geometry goes from geometry in memory to stuff on the screen. So like for instance, for those of you who may be old enough to have played like an N64, those did not have a programmable pipeline. So any graphic stuff on there was assembly code written for that specific graphics chip. Yeah, and then I think it was maybe Quake where OpenGL kind of became a thing where the programmable pipeline became. And again, so the idea behind GLSL is for you to be able to program different parts of the rendering chain for your graphics card. So, for instance, I've got some triangles that represent, I don't know, a mesh of, I don't know, Link running around, right? Well, my camera might change where I'm looking at of those triangles, and that's one of your shaders may do the camera work to sort of position those triangles and do some matrix math to rotate those around. And then you might say, well, here's some image data. I'm going to write another shader that takes that image data and kind of maps it onto those triangles. And so
does SL stand for shader language?
Correct.
Okay.
So GL is an OpenGL.
Right.
SL.
Like graphic language, shader language.
Exactly. And then for Windows, there's HLSL, which is high-level shader language. And I think now with Vulkan, which is kind of a successor to OpenGL that's more modern, they have their own sort of way of doing it, as well as if you're a Unity person, Unity has their own way of doing this kind of stuff too.
So these, like the L meaning language, does it end up looking something like an XML kind of a markup language?
Looks
or
like C.
Looks like C.
We can look at some examples.
So like a good example of a shader that you've probably seen is like a chromatic aberration, I think it's called, where it's like where you've seen like an image and they'll like split out the red and blue and they'll kind of like be phase shifted a little bit, where like it kind of just gives that 3D vibe look. So it's all about like taking the pixels and doing little shifts in colors and stuff to add filters and things on top of the imagery.
So basically, as an input, so again, we can totally get into this. Like this will be a great talk. Maybe not from the Python meetup, but it was still very cool stuff. But yeah, so basically, your shader is basically a function that takes some input and and gives some output that's a color, right? And the input might be the geometry, like or a pixel or UV coordinate or something like that, right? And then you say, well, how do I figure out the color? Well, I could ask my texture, hey, at this coordinate, are you blue or what kind of color are you? But there's other kinds of stuff you can do. And you can see there's all kinds of cool stuff in GLSL where you can like take the XY coordinate all together and then like do stuff, I don't know, it's like it's really cool stuff. And then you really get into this sort of like vector math. Like you're really gonna have to know your sines and cosines because
Oh no, David.
and some vector normalization, and then you've got some swizzling going on, and some really cool stuff going on you can do, and it's a really cool. It's different than like other programming from what I've experienced, but because your program that function runs per pixel. It's worth noting that function is going boom for all of those pixels on the screen.
It's gonna be fast.
Yeah, so you can't get too crazy. In fact. In OpenGL, there's a limit on the size of your program. So if you have too many statements, it won't fit into graphics memory and it'll get rejected.
Is swizzle a real term, or do you just
Swizzle is indeed a real term.
Swizzle. You're just like fill in where
No, man, no.
Swizzle. Okay.
Boom. It allows you to swap XY coordinates. So you can instead of going .xyz, you can do .yzx, and it flips the coordinates around like that. Isn't that cool? Yeah. So you can see. That example right there, yeah.
Very cool.
Yeah, so it creates a new vector with the W's there and something.
Matrix computations.
Yeah, oh yeah.
And that's why these are so good for like the machine learning that's doing like the matrix computation, is because it's basically like
Graphics cards are really good at matrix math.
It's all figured out.
Yeah, they're really good at it. They're really good because SIMD stuff. You can get into, I have this whole vector and this other vector. I want to add them. Well, I do it in one instruction rather than doing a loop over each one of them. And I think NumPy under the hood is doing some of that stuff for you. So like that's one reason why like you've got arrays and stuff. NumPy is really awesome because it can do that kind of math really fast. And again, coming back to the art stuff, you may have to do that kind of calculation to build your cool image. Well, you might have to add like 1 million vectors, and doing those in chunks of 64 or whatever your CPU supports, or if you're crazy, get into CUDA stuff and do it all in one go, So there's some really cool stuff that way. But yeah, so that's why NumPy's great, right? I have my qualms with NumPy. We can do that another day. But what's up?
Yeah, I wanted to suggest if someone wants to try fractals but doesn't know where to start, there's a very simple but very interesting one. It's called Stern diatomic sequence. So if you STERN, Stern.
With M or N?
N as in Nancy. Diatomic sequence.
Theta sequence?
No, not data, diatomic.
Oh, spell that.
D-I-A-T-O-M.
And then
M-A-C.
STRN as in Nancy.
Oh, okay. Ooh, that's cool.
It's like 5 lines of code. Literally. It's very simple. Yeah, if you scroll down a little bit, there's the computation rules for it, like at the bottom of the screen.
I'm waiting on the browser to let me. Oh, we did it. There you go.
Yeah, so the figure number 2.
Ta-da!
Yeah, that's it.
That's cool.
And
That's the fun part about this is like now you got this like you can just build SVG files and now you just gotta find some like random little stuff like this and you stitch them together and you get some really kind of funky stuff and you can map those onto a circle or something, right? And then it kind of.
I can tell a funny story about how I came about this. I was actually preparing for an interview.
Okay.
I was like on LeetCode and this thing popped up and like, hey, find the like maximum of the sequence for x equals whatever. And it looks like primitive. It looks trivial, but there's no way you can like predict this value. It's only like recursive computation.
Mm-hmm.
So what I ended up doing is. I abandoned all the hope for. So I just started drawing this sequence with rainbow colors.
Yeah,
that's awesome.
That's cool.
Yep.
But yeah, so you can see
I
how
still passed the interview though.
there's just so much stuff like that, and again, part of it's like knowing like all the right tools to kind of stitch together, right? That's kind of the lesson, right, that I've kind of learned, right? So that there's so many out there, and so it's find the ones that you like working with. Like Dave and I were talking about the XML, built-in XML libraries in Python are really clunky to me. I do not like using them, and that's why I ended up kind of going the right idea. Like, oh, I need to build some SVG. Oh, I do not want to use those XML libraries in Python. So that's how we ended up with that tag function. I can show you my my version of that.
XML is awkward in all languages.
Yeah, it's
It's not a good format.
Let's see. Let me see if I can find it real quick, and then you can see the
Sax parser, or like just one of the few styles, and none of them are good.
Well, I don't know if I can find it fast enough. I know that people probably want to.
Hard to fix.
Yeah.
Haha. Haha. Hey, look at that. That looks familiar, right? Look at that strong typing. So that looks pretty familiar. You can see, I think if y'all remember, I mentioned replacing underscores with the dashes. Yeah, and it's mostly the same as what we actually coded up in front of everybody. And then I was able to build all kinds of cool stuff that way. So, and I did some typing. So you should totally use typing.
Nice.
Anyways, all right, I'll shut up. Thanks y'all for coming.
Thanks, Joe.
Thanks y'all. This is great. Thank y'all. This was a lot of fun. I had a lot of fun.